All right, welcome back for my second time. This is now the planned session, and I'm happy to show you more now about the current market situation and the possibilities behind it, and what we did with the current market feedback to go really the longer way for stable production setups for the future. So, DENKweit developed DENKnet, and beneath DENKnet, there are different, there's a whole variety of technology behind it. The first one is the DENK Vision AI Hub, which I will show you in a sec, and more in detail, or the things, and for sure as well, the integration part to use your networks in the production phase. And therefore, we do a highly complex image evaluation simply implemented. 2 words from the DENKweit side. So we are founder of a spin-off and are now 5 years, more than 5 years on the market, and have therefore more than 5 years of experience in the vision AI industry. Our aim is that we make high-performance vision AI applications and perfectionize them for the industry and make them, as you already saw in my first session, make them easy, accessible for everyone. So everyone can use it, maintain it, and use it for the future. And therefore, we want to generate value for our partners. Now I want to go to some the current market situation, and especially now you see regarding ChatGPT and using other tools, those AI tools are growing. And I heard a really nice quote, but I cannot remember where it came from. It is, we will not be replaced by AI, but by the people who use AI. So those tools are growing, and we need to get to use them and the technology behind it. And especially, as you can see, as ChatGPT as well, the usability is so easy that the potential is high to reduce costs for different kind of things. The second part is, as I already mentioned, there's, especially now in this time, reducing costs at almost all levels. You see there's a lot of hiring employees in bigger companies. There is, you have to look where the money flows, but you need to remain and retain the same quality and functionality of the current production setup, which is run in the productions. And therefore, you need tools or applications which are easy to use, easy to maintain, and have it like for the future proof, okay, even with lower employees or not the right people, maybe to have it accessible at your needs. And this is the third part as well, the expert knowledge. Usually when you want to create your own vision AI or AI examples or applications, there's usually a lot of expert knowledge needed. Okay, how do you create the layers, how to optimize it, how is the training running, and so on. So the setup time in the standard process takes up to 3 to 4 programmers. Okay, there's some other examples as well, but we need to push more in the easier setup as well, and focus especially for those applications to the input, because the input equals the output. And therefore, the better the input is, and you have there the knowledge, okay, how do you take the image? What are the defects or the quality you want to detect on your products, and how to optimize those processes to obtain and maintain the quality, so that you have a good setup for this, and then you can build up for example, quality assurance, and have then with the DENK Vision AI tool to build up your quality control and have a good output, okay, to use this quality checking tool as well. And therefore, you can use your expert at your companies in the more dedicated fields, which is possible. The fourth part, which I see coming up right now, especially there are a lot of stations going or building up right now. The topic is really interesting in those ones, is you have island solutions and corporate solutions. So usually you have like one application, there's a standalone PC where the quality will be checked. But when you think further, you have to take in mind, okay, people come and go, and you need standards throughout the whole corporate companies to have a really one standard and have the process like for the quality control, a digitalization of what is really a defect and what is not. and therefore you have to handle with multiple users which are maintaining the system, and have multiple systems for different kind of projects which you need to think about as well for future applications when you want to use Vision AI applications. So therefore, the result is that DENKweit built up an easy tool to use AI, as you already seen in my first session. And we have really looked into the setup time. So we want to reduce it as much as possible so that you get really fast within minutes to a working Vision AI solution. And the more important part, have a quick and easy solution to maintain the high quality standard you have on your company side. Therefore, as you already see, okay, when you know your defects, you know what you want to look at, then you can apply those ones directly to those images by annotating it, and don't need any experts to set up the networks behind it, where you have to tweak parameters or so on, which is a really complex thing. And therefore, you can drive your standards to the next level and have really a corporate solution where different kind of people, even around the world, can work together to optimize your quality control and have set standards throughout the whole company. So we do image analysis in just a few clicks. How to do it? It's really simple, as you already saw. Step one, you upload some images to our DENK Vision AI. Then you choose the technology, or when you don't know which kind to choose, you can go to a network wizard and you get a suggestion to start your application. And step three, as I showed as well, the annotation process, really simple. Just mark on the image what you really want to find. Continue this on 15 images, start and press the button play, and the network will be created in the background. And there you have the play button. This is kind of our play button as well. So we know AI because we want to go from the beginning, like setting up the Vision examples, but we want to cover the whole entire life cycle. Therefore, with the DENK Vision Hub, you can generate and optimize your own image evaluation with different kind of technologies where we have the strong and technological background in our platform digitalized, so you can benefit from this optimization. The second step is to integrate it, test it, and ramp up. So when you have those systems building in your current setups, you have a build-up phase, a ramp-up phase, where you have to check, okay, is it working or not? And therefore, I have a really short and close ramp-up cycle where you can easily improve your own setup to your needs, so it's working in the process 24/7. And the most important part is you can optimize and stabilize for your long-lasting AI solution. Even when there's something changing in the production, you have the possibility, come back to the Vision AI, set up or take a new image into the training. The AI learns on top, so it gets better and better over the time and generalizes more on the defects you want to concentrate on. And you have a long-lasting AI solution, even like in a couple of years as well. So what can DENKnet do? Some people may already know those examples. I will go a little bit more into detail and tell you about some examples we do with the customers and our partners. So the first thing, okay, we do matching. For example, like here with the object detection, you want to find parts, where they're located, how many of them are there, and so on. And this is easily done with the object detection in our DENK Vision AI Hub. This is use case number one. Number two, and this is our main focus, where we started 5 years ago. This is pixel accurate detection. So for example, scratches, even like positions, as you saw with the circuit boards in the upper field, you can find the rotation of it, pixel accurate, for finding it precisely and handling it later with a robot, for example. Other defects, so it's like a universal technology, and even when it's accessible with just 15 images, you can build up such a strong and high image evaluation with just marking those defects to find, especially how the detailed things in your production. So later you will get out, okay, if there's a defect, how long is the defect, for example, when there's a scratch in it, how is it changing over time, especially you can have this at a view, are they getting bigger, and so on. And yeah, it's a very good technology which we recommend almost all the time. So we are really good in pixel accurate detection as well. Other examples for just simple ones is counting. So you can easily do this for the same objects or different kind of objects, depending always on the approach you have. Then this count. I go on a little bit faster through it because there are some more easy applications. You can see here there's an image evaluation created with just 21 images for a quality control of those tips. So in the middle and the right image, you see there's a defect or there's a round tip on it, and the perfect one is more the peak one. And as you can see, it's already working with AI perfectly, and the customer is very happy at this point. So easy questions for good and bad decisions are made simple with the classification of this. This is a really nice use case because this shows that we don't have any limitations on our DENK Vision AI Hub. So even when you have big images from microscopes, from whatever camera we heard previously about different kind of more pixels coming in to the market, we can even detect on the smallest part those defects. So you have the whole part in check and see, okay, where's the defects, maybe always occurring on the left-right corner or so on, to find those one and have a really good product which you can deliver to your customers. So we can process super big images as well. There's kind of a standard application. It's like the deviations with the anomaly detection, where you train with just the good images and you don't know which kind of defects occur. Then you can use this technology to find the deviations from the good processes. So you can detect their differences and so on. This is another nice example which demonstrates or showcases that we are not limited in the creation of classes. Sometimes you have a big defect catalog and you want to differentiate between everything you want to find on those images or on those parts you want to check. And in this case, we are working with a partner together who is checking for the street signs and street elements like so side blank, there's some, where the water flows in, I don't know the English word right now, and so on. And the customer set this up by themselves. And as you can see in this whole list, there's just a couple images needed for every class to be trained, and therefore working now perfectly in the production environment. So we do not have limits there and are limitless in the label classes. And our newest feature now available at the DENK Vision Hub as well is our text reading. So especially in the production environment, and you want to create products or have markings on your cartons and so on, there are always numbers, everything is checking and so on. But sometimes those environments are difficult to read texts as well. And therefore you can just train an AI finding the text you want to read, and then use our own DENKnet OCR reading to use it in your application. In this case, we have a pre-trained network, so you can apply this pre-trained network directly on those images and see the results. And in 95%, those results are already perfect enough, so you can easily integrate it and use it right away. If the text reading is not working, and this is sometimes the case, especially on needled or laser dotted imprints, then you can just take those images, do the same process as I showed you in the DENK Vision app. So upload some images, annotate those images with the correct text, which is found on the image, train an individual DENKnet OCR network for your needs, and then you can implement it in your case. And then you can read all your texts you want to have in your setup. And now available as well, we do code reading on top as well. So this is a very big, broad use case examples which we do and offer you in the DENK Vision app the tools to use it. If you have other kind of special use cases as well, always have a talk with us or with IDS to find out, okay, is it the right approach, where we can set it on? But I think there's always a possibility to set up your solution. And there's much more. And this is a really nice part I want to come in right now, because we love your feedback. So if you have suggestions about, okay, what is needed in the development to make your process easier, better, faster, or get better results, always come back to us and we will have a look, integrate it, and push it to the next level. And regarding this one, we love your feedback. We can now look into the past, the last 5 years, what we did with your feedback already in our DENK Vision AI Hub. So the first thing is the time for annotation. Usually when you set up some applications, you have to annotate a lot of data. So above 1,000 of images and so on. And even like on every image, every single defect needs to be annotated. And what I showed you already with the one-click annotation tool, which I come back in a sec, you can save so much time using it. In this case, what I want to show you right now as well, this is you can use the prediction of the AI, convert those into the annotations. So you confirm those as a user and have it as an annotation, and put this back into the training. So the AI gets a confirmation, okay, what the defects I found are right or wrong, so you can adapt it, put it back in the training and have really close updating cycle. And the second part, which I already mentioned, is our one-click annotation tool, where you have just 1 to 2 clicks, confirm those dots or the positive and negative points, and annotate this image very, very quickly. And it makes now a lot of fun for me as well. I can talk from my own experience. There are some live demos I can do with really just within a couple of minutes, and the annotation process takes less than previous one a couple of years ago. Second, the next thing is the quality of the data set, which I already showed you. In the process of setting up an AI, we see always there's one big problem when setting it up, and this is the quality of the data set. So the input needs to be perfect so that you have a perfect evaluation method as well. The AI can generalize it, but as more defects are in the data set, in the training, the worse of the performance later on. And we want to focus on this key part to save money in the setup phase. And therefore, the same thing what I just showed you now here just with an image is our data quality center, where you can compare the annotations to the predictions and can find, for example, some missing pieces which you forgot to annotate, so you can improve your current data set. And you see when the prediction is not there or not perfect on those images, that you can have to insert there some images for those special use cases, for example, a very special defect or a very special product category, to optimize this data set to train the AI better. So with the data quality center, we provide you as a service in the tool, you get insight into data set and get suggestions about how to improve those. Furthermore, we want to provide the highest performance as possible. This is our most important part, and this we can reach to our own leading technologies in our backend. As you already saw, you have just a start button, just press play, so you don't have any settings to start your own training. You don't need to set parameters and so on. And because of our unique network architecture search, the perfect solution will be found, and you just need to press play. And here in this image, you can see as well, there are just 26 images needed for this perfect Vision AI solution. And it starts from 15 images and so on. Maybe just a word on this case. When you want to start, you start the training and see the results of the AI, then you really have a look on those images where the AI is not performing correctly and put exactly those ones into the training, because the AI learns on those difficult images the best. And therefore, you have a short update and maintaining cycle for your production setup. Next part is the decisions adapted to your own applications. And therefore, as I already mentioned, you have the first part is the AI, which you can generalize for all the defects you have, and then set the settings to, okay, I want just to find this kind of defect with this kind of size, counts, and so on. And therefore, you have just some parameters you can touch without touching or training the AI on this case. But maybe just a side note, you always can specialize your to train your AI for just finding those defects with this kind of size as well. So there are multiple approaches, but what we recommend is always, okay, we go the general way, find all defects or find all applications, find products and so on, and then you set the parameters just as you need so you can adapt it for later. So for example, this is another one on the left side. You can set some bucket sorting and filtering options where you can filter by the size of the area, the probability of the AI, and for counts, for example. Tune and test your yield. So the most important part is that you have your production setup at hand and see if there's something changing, and you need to quickly make changes if there's, okay, we want to drive a lower quality set or a higher quality set running through the thing, and you want to improve it as fast as possible. And we make those things visible in our tuning center, where you have at hand an overview of images and predictions from the current setup, and see, okay, how is your AI performing? How is the results performing in combination with the recipe from the decisions you did previously? And then can set up the point, okay, where should the sorting be? Where's the sort out threshold and so on? You can easily set up those. Furthermore, which I already mentioned in the beginning, working with several people, local or regional, everyone has a different opinion, and the nice thing about it is we can deal with it. And that's exactly what we did with the user annotations, a user history, for example, here, where you see, okay, what kind of people, colleagues trained the image in this case, okay, what was changed over the time. And you have kind of user management in different roles. So there's an expert, there's a user. So you can provide always the highest quality to your production standard locally to one setup as well, but you can broaden this out to multiple stations, even worldwide. And we can drive AI experience, kind of those where you can see, okay, when you let people like 10 or 15 people train on the same image as well, how the defects will be annotated. So if it's a defect, yes or not, and can standardize those defects for your needs. So you can use the rule of the masses, I think it's called, for the further developments and standardization of your processes. And with that, you have always the possibility, okay, working on multiple applications. So you have advanced group settings, guests and roles without limits. You can invite support groups. You can invite other people from different company standards. So you can work together worldwide, find the right solution, the right approach, optimize your vision solution, and have everything at hand so you can manage your applications even worldwide. And the last part, and not to neglect those, is how to self-integrate it. We have different kind of approaches there, or use cases, which you can use. So when you have your own program, you can just use our DENK API, which is a library you can just integrate in your program. You put the image through and get your evaluation there, and then can continue to the own processes. Or which we push now forward extremely, is our DENK Easy Check. This is an application with a visual graphical user interface where you get the evaluation at hand and have then the metrics of the last process as well, how this defect size changes over the time, and so on, different kind of settings for your own needs, so you have it all at the end, at hand. With that, I want to close. This is always the call to action I have. So do you have images? And we can do a demo to provide and show you, okay, what is possible in your specific use case. And yeah, thanks for your time.
you, Arvid, for your interesting talk. So again, there's not only the question, do you have images? Also, do you have questions now? So please bring them and just ask Arvid certain questions. One is just coming up. With which kind of software trained networks can run on machines, on production machines? What kind of software is needed?
So you have different kind of levels. When you have your own software, you can, as I mentioned just at the last slide, integrate our library to have it in your own production setup and maintain the pipeline process of image acquisition to the evaluation at your own part. But we work with other partners as you as well, where you can use our networks in the complete process using it. So the other option I mentioned, which will coming up soon, is the DENK Easy Check. But there are different applications or softwares as well. So just contact us directly and we can provide you with the right solution for that.
Okay, and let's say according to this, there comes the question of what are the hardware requirements to let a DENKnet run?
Yeah, so we go the standard way and suggest using a GPU. So depending on the process and your needed evaluation time, we can recommend different kind of GPUs. If you have just a simple setting of just every once a minute or so, check it if a product is there or not, is the quality good or bad, then you can have low standards for the 1080 or can run it even on an internal GPU. But for fast processing, fast processes where you have high images, large images, and high requirements with a lot of defects you need to detect, you have always to go to a higher performing GPU like a NVIDIA 3080 and also on.
Okay, there comes also additional to this the question, is a CPU also possible to let it run?
Yes, but the standard which we always recommend is using a GPU, but depending on the process, which I mean when it's really low, maybe I had an example where the door was checking if it's open or closed, it can be run on a CPU as well. But this is not our main suggestion.
Okay, perfect. So no more questions open. Arvid, thank you for being here to give us some insights into DENKnet and the company DENKweit. Thank you very much.
You're welcome.